Hello, my name is Jordan.
I'm Olivia.
And my name is Savannah.
Our research question is, what effect does microgravity have on the germination of mustard spinach seeds?
The scientific name for mustard spinach is Brassica Rapa. This edible plant originates from Japan, where it is known as komatsuna.
We are proposing this study because Brassica Rapa is a strong candidate as a useful plant for supporting the health of astronauts and long-term space travel.
Our proposal focuses on Brassica Rapa's vitamin C content, which has strong antioxidant properties that can protect against cancer, strengthen immunity, and support bone, eye, and heart health.
NASA reports that edible plants have been successfully grown on the ISS. We hope that, one day, mustard spinach will germinate and flourish in microgravity.
Brassica Rapa is a leafy green, commonly known as mustard spinach. It grows quickly and easily, and is a highly nutritious vegetable that can be used in food in plethora of ways.
Brassica Rapa is primarily used in Asian cuisine, including stir-fries, salads, and soups. Even the stems are edible.
A 1 cup, 150-gram serving of Brassica Rapa is only 33 calories and contains no sugar and only 1 to 2% daily value of total fat, sodium, and total carbs. It contains 7% daily value of protein, 15% daily value of dietary fiber, and 82% daily value of vitamin A.
Brassica Rapa could be highly beneficial to astronauts in numerous ways because of its high vitamin C content, that means 217% of daily value. Research has found that taking oral vitamin C supplements does not appear to offer the same benefits as vitamin C from eating whole foods such as Brassica Rapa.
Antioxidant nutrition is necessary for the health of astronauts and long-term space travelers because of their exposure to higher than normal levels of radiation. Vitamin C is high in antioxidants and strengthens the immune system, reduces risk of developing cancers, develops healthy bones, skin, and blood vessels, supports eye health, and prevents vision loss, helps form and maintain connective tissue, and can lower blood pressure. Our field expert states that Brassica Rapa seeds germinate quickly and evenly at a rate of 70% or higher in optimal conditions. Brassica Rapa requires full morning sun to light shade and prefers moisture-retentive, nitrogen-rich, well-drained soil. It grows best at 45 to 85 degrees Fahrenheit, which should not be an issue on the ISS, where we expect the seeds to be kept at approximately 70 degrees Fahrenheit.
We will use an organic seed starter recommended by our field experts. This substrate is sterile and contains nitrogen as well as gypsum, which helps plants to use nitrogen more efficiently.
The seeds on the ISS will not have sunlight, but will have the moisture, healthy soil, and temperature that they need.
We also expect Brassica Rapa seeds to germinate in microgravity based on prior studies. NASA reports that red romaine lettuce grown on the ISS was found safe for eating, and the astronauts said it tasted good. Also, preliminary findings from the Tomatosphere program indicate that tomato seeds germinated in microgravity similar to on Earth.
Our primary hypothesis is that the Brassica Rapa seeds that have been exposed to microgravity will germinate similar to Brassica Rapa seeds that have not been exposed to microgravity. Our secondary hypothesis is that the Brassica Rapa seeds that have been exposed to microgravity might germinate differently than the Brassica Rapa seeds that have not been exposed to microgravity.
If the Brassica Rapa seeds on the ISS germinate similarly in comparison to the Brassica Rapa seeds on Earth, hopefully one day mustard spinach will germinate and flourish in microgravity, providing astronauts and future space travelers with a fresh and healthy source of the antioxidant vitamin C.
We will be using a type 3 mix stick.
Section 1 of our mix stick will hold 1.5 milliliters of distilled water. Section 2 of our mix stick will hold 15 Brassica Rapa seeds and 4.5 milliliters of dried organic seed starter.
And section 3 of our mix stick will hold approximately 2 milliliters of liquid formalin.
We are asking the crew at time A=0 to unclamp A and shake gently for 5 seconds, and at time U-2 to unclamp B and shake gently for 10 seconds.
When we receive the sample back from the ISS, we will compare the germination rates as well as the average mass and size of the germinated seeds between the two samples.
In preparation for our study, we have loaded a mock mix stick and are attempting to germinate seeds.
Our proposed study is a starting point. If our results indicate that Brassica Rapa seeds can germinate in space, NASA scientists can further study mustard spinach. Maybe they can try to grow it in plant pillows and that they have successfully produced other plant foods.
NASA determined that the nutrients of foods taken to space did not decrease faster than the nutrients in the same foods on Earth. We hope that the nutrients in mustard spinach grown in microgravity stay the same as they do in mustard spinach grown on Earth.
It is also possible that future Brassica Rapa studies may build on prior NASA research that has shown that caring for growing plants in space is beneficial to the emotional and psychological health of astronauts.
If our experiment is selected for flight, we will invite ILEAD learners, first from Agladose, to apply to join our launch team to help with fundraising, developing our presentation, and conducting research.
We would love to grow mustard spinach in our campus garden that we could share with our community.
We would like to share our Dream Up to Space story in our school's Monday message and social media, other ILEAD communications, and local news outlets.
We would like to acknowledge ILEAD faculty and administration, our field experts, and our family members for their support and encouragement.
Thank you for your time and consideration.